Hey, today we're going to cover a couple of more sorting and searching algorithms to search and sort our arrays. We already covered the sequential searching algorithm, and today I'm going to introduce some of the sorting algorithms too. So we're going to start with the bubble sort algorithm, and bubble sort is very useful when you want to sort your array in an alphabetical order or if you want to sort it in a numerical order. But yeah, bubble sort is a sorting algorithm. It's not a searching algorithm. So how does this algorithm work? It's pretty simple. Let's declare an array of numbers. For example, it doesn't matter which numbers we have. 17, 16, 7, 4. Doesn't matter really. So we have our array of integers, and let's say we want to sort it in an ascending order, so from the lowest to the highest. All that this algorithm will do, it will take the first element, 24, and it will compare with every single element in the array. So let's find where 24 should be placed in our array. Let's compare it. We're going to compare it to the 17. Is it greater than 17? Yes. So right now our array will look like this: 24, 16, because we swapped them. 4. Okay. Now we are still looking at our 24, at our first element originally. Then we're going to compare it with the 16. Is it greater? Yes. This is what it's going to look like: 17, 24, 7, 4. Okay, let's move on to the next one. And we just keep comparing this element until we find a spot for it. Okay, so let's compare it with the 7. 24 is greater than 7. Then we move it again. 17, 16, 24. Oh, my bad. 7, because we swapped them. 24, 4. Okay, we're almost there. We almost ran out of elements. And we're going to place our 24. We're going to compare it to the last element that we have. Is 24 greater than 4? Yes. So this is going to be our array after the first execution of the bubble sort algorithm. This is after the first step that we did. Okay, so this is the array that we ended up with after our first pass of the bubble sort algorithm. So, and the next thing that we do is simple. You take the first element and you repeat the same thing that we did. And if we compare our first element, 17, if we compare it to every single number that's here, we will end up with something that's going to look like this: 7, 4, 17, 24. Because when we are going to compare 17 to our last element in the array, 17 is going to be less than 24. That's why it's going to be put in this position. All right. And then literally all we do, rinse and repeat. Look at our first element, compare it to everything else. So by the end, after you're done this with 16, with 7, and with 4, you're going to end up with a perfectly sorted array in an ascending numerical order. It takes a long time to sort our array with this algorithm, but it's one way to do it, and it's a really simple code. It's really simple to write it out, but yeah, this is the bubble sort algorithm. Our next algorithm is going to be also a sorting algorithm, and it's called the selection sort, and it is similar to the bubble sort, but it is more efficient and it works better because when we use bubble sort, we only move one element at a time and we compare that element with every single other element in the array. But with the selection sort, we perform fewer swaps because the selection sort algorithm does two things, and let me show you what it does. So you have to imagine the selection sort that it kind of works in two ways, in two steps. So the first step, step 1, is going to be to scan. Oh my, sorry about that. The first step is going to be to scan the whole array. And after that, what it's going to do is going to find the smallest and largest element in the array. So we're going to find the maximum number. Let's take an array of numbers. We'll take the largest number and we'll take the smallest number in array, and then we're just going to swap them. With that way, our array can be sorted in smaller amount of steps. So in this example right here, we have an array of integers and we need to sort it in an ascending order. Let's do it the same way as we did with the bubble sort, just different numbers. So what this algorithm is going to do, remember step 1, it's going to go and scan through the whole array and find the largest and smallest number. Okay, so we found this largest and smallest number. We found 64 and we found 11. So what we're going to do, we're just going to swap them. We're going to have 11, 25, 12, 22, 64. We just swap them. Since we scanned the whole array and we know that the 11 is the smallest value, we do not have to work with 11 again. 11 is at its right place, so we're moving on to the next element, and which is going to be 25. So how we're going to work with 25, the same way that we worked with 64. Let's find the smallest element from the elements that are unsorted, because remember 11 is sorted already. We don't touch 11 anymore. It's at its right place. So let's look. 25, 12, 22, or 64. 12. 12 is the smallest element. So what we're doing, we're just going to swap these two. After swapping those elements, this is the array that we're ended up with. And now the 12 is at its right place. Okay, then we don't touch 11 or 12 because both of those are sorted. So we only have 3 elements that we consider non-sorted. And we're going to take 25 and we're going to find the lowest element. What is the lowest element from the unsorted elements? 22. Then we just swap them. And after doing that, this is the array that we're going to end it up with right here. And it's perfectly sorted in an ascending numerical order. And it only took us 3 steps to do that. And with bubble sort, remember, it took us a long time to sort. And with this algorithm, it only took us 3 steps. So everything that you have to remember about the selection sort algorithm is that it works the similar way to bubble sort, but it scans the whole array for the smallest element, and then it just swaps the two. Swaps the element that you're working with the smallest element in the array. And the last algorithm that we're going to cover today is called the insertion sort algorithm, and it's also similar to the bubble sort, but it is more efficient than the bubble sort. And let me show you how it works with an example. What this algorithm is going to do with an array that we have right here of numbers 11, 13, 5, and 6, and let's do the same thing that we did with the other algorithm. We want to sort this in an ascending order, so from the lowest to the highest, and we see that this array is not sorted, so let's do it with the insertion sort algorithm. Let's look at our first 2 elements. So what this algorithm does, it looks at the first 2 elements, 11 and 13, and let's look and see, are they sorted between each other? Are they sorted between each other? Yes, they are. 11 is less than 13, and 11 is on the left side of the 13. So how it should be. Okay, let's look at the next one. At 13, let's take the next 2 elements, 13 and 5. Are those sorted? No. So our second step would be to swap them. 5, 13, 6. I hate when it does that. It's so annoying. Those lines appear. So this is what we're gonna end up with. Now we're not done, because 5 is splitting our 11 and 13. So we take the 5 and we look, is 11 less than 5? No. Okay, so we swap those two. 5, 11, 13, 6. Okay, now we look at 5, 11 sorted, 11, 13 sorted. Now let's look at the 2 elements 13 and 6 right here. 13 and 6. Are those sorted? No. 6 should not be on the right side of 13 because 6 is not greater than 13. Alright, let's put it on the left then. 5, 11, 6, 13. Is our array sorted now? No, because 6 is not at the right place. 6 and 11 are not supposed to be like that. 6 is supposed to be on the other side of 11. Okay, let's flip them then. 6, 11, 13. Here we go. We sorted our array with the help of insertion sort algorithm. Okay, a swap module. So it's a concept that you need to be familiar with called a swap module. And have you noticed that almost all of our algorithms, they are based on the action of swapping some elements with something, right? Swapping the two elements. So instead of typing that out every time, swap A was swap element A was element B, instead of writing the code for that, we can create a module right here that is going to do it for us. All it does, the swap module, all it does, it takes your integer A and an integer B and just swaps their places. That's all it does. So if we had, for example, 14, 7, 8, 9, 11 integer, and for example, if you wanted to swap 14 and 11, all this module would do, it would take 14 and 11 as its arguments, and it would just swap them. So this is what this module would do for us. 9, 14. All right. And it's useful to write this if you need to sort a lot of different arrays or a lot of different lists. It's useful to write this module out and just use it in your code for the algorithms instead of typing this out every single time you need to swap two characters or two integers. All right, so I think one of the most important searching algorithm, this is a searching algorithm, not a sorting. We're done with the sorting algorithms. The one of the most important searching algorithms that is still used to this day and is very popular is the binary search algorithm. And remember, binary is a system that comes from the binary. The word binary means two, so two elements or two of something, because remember the by part means two. So how does the binary search algorithm works? So for example, we need to find an element in an array, a certain element. We need to know where it's located, right? So what we're gonna do is we're gonna divide our array in half every time we search for that item. Let me show you how it works. So first thing that is required, your array needs to be fully sorted. So use any of the algorithm that I just covered to sort your array. Let's take one of the arrays that we worked with already. For example, let's take this one, the one that we did with the selection sort, 11, 12, 22, 25, 64. All right, we've got our array, and let's say we need to find an element 25. Right, this element, we need to find where it's located. What this algorithm is going to do, it's going to look at the middle element of your array, and our middle element is 22. So what we're gonna do, we're gonna look at this element 25 and we're gonna think to ourselves, is 25 greater than 22 or less than 22? Or is 25 22, the element that we're looking for? Is it 22? Well, it's not 22, so it's not the element that we're looking at, and it is not less than 22, so it cannot be on this side of the array, so it is on the other side of the array. So all we're gonna do, we're just gonna get rid of this part. We're gonna discard it. We're not gonna look at it, including the 22. We're not going to look at this at all. This part of the array does not exist for us anymore using this algorithm. Now, let's move on. And we have only two elements left, but we're going to look whenever you have a even number of elements in your binary search algorithm that are left, it's going to take the one that's on the left. So let's find the middle of the rest of our array. The middle is right here. We don't have an element here, and as I said, we look at the element on the left, and oh, we found the element on the left. It is exactly what we were looking for, 25. And if your array is bigger, if your array has multiple numbers, like thousands of numbers, this is exactly how this algorithm will keep going. It's gonna split your array in half, look at the number that's in the middle, and then compare it to the element that you're looking for. And if it's greater, then the number must be in the first half of our array. And if it's less than, then the number must be in the second half of the array. And then you just keep going until you find your number. Exactly what we did here. Just keep discarding one of the halves of the array until you get to the number that you're looking for. These are the codes for writing your own bubble sort in Python, for writing your elements. I can post screenshots of these codes if you want, or you can take a screenshot of this code as you're watching it. So this is the bubble sort, this is the selection sort, this is the insertion sort, and this is the binary search. I will not go through them. However, the comments are very helpful. The comments explain everything that's going on in each one of these algorithms, and just be familiar with what it looks like. And that is it for today. Have a good day.